Okay, so we are looking at section 4, arrangement of the periodic table. We are on unit 2, and this is page number 8. So the periodic table is arranged to show relationships between different elements. It is a model. Back to your unit 1 notes. A model is something that we use to describe a scientific principle. This model is used to describe the periodic law. So looking at the periodic table, it's got vertical columns, it's got horizontal rows. A horizontal row is known as a period. Horizontal meaning left, right. Elements are located in periods based on their electrons. This is a topic that we might discuss more in a later unit. Vertical columns are known as groups or families. So we're talking about vertical. So just like you may share some similar physical traits with a sibling or a cousin or a parent, elements and families tend to have similar chemical and physical properties. For example, let's compare groups 17 and 18. So get your blue periodic table out of your binder and take a look at it. So looking at group 17 with group 18, all of the elements in group 17, fluorine, chlorine, bromine, iodine, astatine, they are extremely chemically reactive. They are unstable. They will react with anything, and they will react quickly and violently. This is a trait that every family member shares. Elements in group 18 are the least reactive elements on the periodic table. They're neighbors. They're right next to each other. Group 17 and 18. They're on the right. Two different families. Two completely different types of behaviors. Just like on your street. If you know there's two families next to each other, you might see that in one house, one family, everybody has a temper. They all react not violently. They all are very reactive to situations. In the house right next door, you might have the most patient family in the world. Something happens and they're not going to react. They're going to be okay. And so even though they're right next door to each other, they're two different families and they have two different ways of doing things. Elements within a family share similar properties. Two different families are going to be very different from each other. So for this section, we're going to be flipping back and forth between page 8 and page 10. On page 10, there's a blank periodic table. We're going to be labeling the general categories. So some groups on the periodic table have names. Other groups only go by a group number or maybe the first element at the top of the column. Group 1A, or Group 1, 1A is the old version. Group 1 are called the alkali metals. Hydrogen is also up there with the alkali metals. Hydrogen is not really a metal, but from a chemical standpoint, it somewhat behaves like the elements in that family. These elements are extremely chemically reactive. So the alkali metals, if you have a pure metal, for instance, sodium is on this list. Pure sodium is highly reactive. It is so reactive that if it comes in contact with water, it will react. It will have a chemical reaction. It could be so violent that it even produces a gas that then catches on fire because of the heat, and then the whole sodium explodes. It's very reactive. Interesting thing about things in this family, these metals also tend to be very soft. Lithium is another metal in this family. Lithium is one of the components of your cell phone battery. Things in group 1 tend to be very good for batteries because they are so reactive. The only potential downside is that if the battery is damaged, then you'll have an issue where it catches on fire. Group 2 elements also have a specific name. They are called the alkaline earth metals. This family tends to be very chemically reactive as well. They'll react with the oxygen in the air sometimes and burn, but they're not so reactive that they react with water. So if they came into contact with water, you'd probably be okay, but they still react with a lot of things. So let's flip to page 10 and let's label these. So groups 1 and 2. So this one is the alkali metals. Group 2 is the alkaline earth metals. So these are the ones we're talking about here. Extremely reactive, pretty reactive. Let's flip back to page 8. Groups 13, 14, and 15 are typically referred to by number, just 13, 14, and 15, or by the first element in the family. For instance, group 14 would be the carbon group. These families tend to be less reactive, at least compared to the alkali metals. They're still somewhat chemically reactive, but nothing compared to some of their neighbors. So let's flip over here. And so this is 3, 4, 5, 6, and so on. 13 is here. 14, 15. Too far. Group 16 elements. Now we're getting back into the realm of things that are very reactive. Sometimes this is referred to as the oxygen group. It's got an actual name. We don't need to mess with it. Group 16 is the oxygen group. The reason it's set apart from 13, 14, and 15 is that it's much more chemically reactive. That's 16. We'll go ahead and write 17 and 18. Top of page 9. Group 17 elements. These are very important. These are called the halogens. Halogens are a very interesting family, and we'll get to talk about them at some point later on. This family is extremely reactive. Extremely reactive, on par with group 1, the alkali metals. So come over here. Here's group 17. These are halogens. And last group for now, group 18 elements are called the noble gases. This family generally does not react with other elements. It doesn't react with other compounds. It's over here, noble gases. It's called noble gases because they don't react with anything. And so it's this comparison with maybe the nobles in a kingdom, the nobility. They don't interact with common people. The noble gases don't interact or react with common elements. And so they stay to themselves. They're somewhat exclusive. Elements can be classified into more general categories than families. For instance, metals. Metals share general properties, like conducting electricity. This is something that most metals do, is conduct electricity. And they all tend to be towards the left side and the bottom of the periodic table. There's a large section in the middle of the periodic table, which are groups 3 through 12. They're called the transition metals. These are your typical metals. If I said think about a metal, this is probably what you would think of. You would probably pick one of the transition metals as whatever represents all metals. Iron, gold, nickel, copper, zinc. There is a separate section at the bottom of the periodic table called the intertransition metals. We move it to the bottom of the periodic table. If you left it where it was supposed to be, the periodic table in our room would be 12 feet long. If you're looking at your blue periodic table, it would make your blue periodic table almost twice as wide. It would require 2 sheets of paper or one really big sheet of paper. So let's go over here. These are transition metals. It is groups 3 through 12. Down here we have the intertransition metals. At the very bottom. If you were going to try to fit these into the periodic table, a lot of times you'll see the periodic table has a star here and 2 stars here. And you'll see a star here and 2 stars here. And basically, this whole thing would fit right here. So in general, everything to the left side and the bottom of the periodic table are going to be metals. On the other hand of this, we have nonmetals, and they are at the top right of the periodic table. Try this again, that looks messy. At the top right of the periodic table. Nonmetals share a lot of properties. For instance, most of them are poor conductors of electricity. They don't conduct electricity well, and when they're solids, they tend to be very brittle. Maybe think of something like glass. Glass is composed of nonmetals, and when it breaks a little bit, it's going to break a lot, and that's brittle. There are some elements that share properties of both metals and nonmetals. These are called semiconductors. Older name for it is metalloids. Somewhat outdated of a term. These elements, especially silicone, are important for electronic devices. These elements follow a stair-step pattern between the metals and the nonmetals on the periodic table. So let's bring it back over here. So this stair-step pattern. A lot of times you'll see a periodic table that has lines drawn like this. Here's the stair-step. And the elements that border this stair-step are your semiconductors. Here's the stair-step, semiconductors. Everything to this side is metals. Everything up here are nonmetals. So the last thing that we can write in here, top right side, nonmetals. So here's the general look at the groups of the periodic table.